Okay, so last topic we're going to look at for Applied 4DS. This one may seem a little bit familiar to you because it includes concepts from set theory and just applies them to probability. So new important term is something called mutually exclusive. So two or more events that cannot occur at the same time, so mutually exclusive events. So we talked about mutually exclusive events in set theory, so it's new to probability now. So when we look at taking the probability of event A or event B, it might be possible that the events may be mutually exclusive. So if there's mutually exclusive, then the probabilities of them happening are individually calculated. So you can see that here, that we're just taking the probability of one event, probability of the second event. Because there is no overlap, the probability of one or the other would just be added together. In a situation where we have not mutually exclusive events, that means there is some overlap. When we calculate the probability of each individual event happening, we have to subtract off the overlap because we double counted. We count A in probability of A, we count B in probability of B, and then we've counted them twice each in that center overlap. So just an example here, first we're going to look at mutually exclusive events. So for example, if we had a pack of playing cards, so 52 cards in a pack of playing cards, the question was find the probability of drawing a heart or a black king. So let's have H being heart. I'm just going to change this to black. H is picking a heart. And then we're going to do B, K as a black king. So if you think of picking a playing card, think of these two probabilities, or these two events. Picking a heart from the playing cards, picking a black king from the playing cards. So there's no such card that is both a heart and a black king. So these two events would be mutually exclusive. There would be no overlap whatsoever. So thinking, what is the probability of a card being a heart? If you remember from a deck of playing cards, there are 4 different suits. There's 13 cards of each suit. So there would be 13 hearts. Now how we change it to probability, remember, top number is getting the heart, bottom number is total number of outcomes. So there's 52 cards in total. Probability of getting a black king in the playing cards. If you think of suits in a card deck, there's 4 of each type of card, so 4 kings, but only 2 of those are black, right? 2 are red. So 2 out of the 52 cards would be black kings. So the probability of getting a black king would be 2 out of 52. So now if we're looking at the probability of a heart or a black king, just like in the explanation above, we're adding the two probabilities together. So that's 13 over 52 plus 2 over 52. So 13 plus 2, remember adding fractions, you add the top number. So that gives us a 15, and the bottom number stays the same when you're adding fractions. So just like remember from before, you can change it to a decimal by dividing top divided by bottom. You can change it to a percent, top divided by bottom times 100. Or you can just leave it as a fraction. To match the answer key though, a lot of times they reduce the fraction to lowest terms. And I've talked about how to match then if you're not doing that. Okay, so the answer of the probability of getting a black king or a red heart, or pardon me, just a heart, is 15 out of 52. Looking at the second scenario here, what's the probability of getting a heart or a face card? A face card is a jack, a queen, or a king, right? They literally have a face on them. So with that, we have to think about what's the probability of getting a heart, what's the probability of getting a face card, is there some kind of overlap there? And there is. There is a jack, that's a heart, a queen, that's a heart, and a king, that's a heart. So those are 3 cards that are in that overlap space. They're all hearts and they're all face cards. So when we calculate the probability of drawing a heart, okay, that's 13 out of 52, plus the probability of getting a face card. Now there's 3 face cards of each type of card, right? 3 diamond face cards, 3 heart face cards, 3 club face cards, and 3 clover face cards. So that's 12 face cards out of 52. But remember, in the formula, we've got to subtract that overlap. So there's 3 that get counted twice. They get counted in the first probability and the second probability. So we have to subtract that 3 out of 52. So what makes this a probability question and not a set theory question is the fact that we've got denominators, right? It's out of a total number. So 13 plus 12 is 25. 25 minus 3 is 22. And with fractions, the denominator stays the same. So the probability of getting a heart or a face card would be 22 out of 52, right? Card games, a lot of the time, different card hands, probability comes into a huge factor. What's the chances of getting that card hand, right? And if you play any kind of cards or you do as an adult, you'll know with different kinds of games and stuff, the chances are higher of getting one kind of hand over another, and that plays a lot into different games that you can play. Okay, so we're going to continue to bring this into another type of question for set that we did in C, which is looking at Venn diagrams. So we can apply probability skills to our Venn diagram questions. And remember, like, the big change is just you've got the denominator, right? Or you've got the fact that it's going to be a percent or a decimal for the number. So 80 students are surveyed. 42 students are in French. 23 students are in Spanish, and 32 are neither. If one student is selected at random, what's the probability of the student being enrolled in one language? So there's 2 different things, French, Spanish, so that we can make a Venn diagram with 2 circles, and then start to put the numbers in. Remember, there's kind of strategies with this from set theory, so this is a good way to practice that set theory stuff. 32 are neither. Remember, that's the empty space out here. So those 32 aren't in either class. So what we can do is, we know there's a total of 45 students. Oh, pardon me, 80 students. I was reading that wrong. Okay, we know there's a total of 80 students. If we subtract the 32 that are in neither, we get 48. So with that, we know that this whole space, let me just show you for a second, this whole space here can add up, or it has to be a total of 48 in all those 3 circles, because we've already used up 32 of those 80 students. So with that, we need to figure out, is there anyone in the overlap? So 45 are French class, are in French class. 23 are in Spanish class. Together that adds up to 68. So that's not good because we don't have 68 students, right? We have overlap there. So if we take the 68 and we subtract the 48, that means we're over by 20 students. So that's telling us those 20 students have been counted twice, and those 20 students need to go in the middle, in the overlap space, right? And now we know 23 in total are Spanish, so we can do 23 minus 20 to get those remaining 3. And then 45 in total are in French class, so then we need to do 45, take away the center number to get the 25. Now the question was, what is the probability that a student is enrolled in only one language? So we know that we're looking at 80 students in total, so that's going to be our bottom of our fraction. 25 students are only enrolled in French. 3 students are only enrolled in Spanish. So 1 language just in French class, 1 language just in Spanish class. So we're looking at 28 out of 80 enrolled in just 1 language, right? So remember, we can apply our set theory information with the filling out of the Venn diagram, and also thinking that the fraction can be changed into a decimal or a percent as well. Next question, find the probability of rolling a sum greater than 8. So sum is adding together, or rolling doubles. So we're rolling 2 dice and we're trying to get a sum greater than 8 or doubles. So with dice questions, it's helpful to make a table to keep track of all the answers. So one side of the dice is a roll of 1 to 6. The other side of the dice is a roll of 1 to 6. And this is a nice way, like if we were in our class and we'd be taking the provincial exam, I would be telling everyone to put a table like this on their study sheet, so you not need to rewrite it for every question. Okay, so first of all, we can ask ourselves, is this question mutually exclusive or not? So can I roll doubles and also have a sum greater than 8? So I can, so I'm gonna have to watch out for overlap, right? For example, if I rolled a 5 and a 5, that's a double, and when I add 5 plus 5, that gives me 10, which is greater than 8. So what I'm going to do in my tables, I'm going to record my sum. So if I roll a 1 and a 1, the sum is 2. If I roll a 1 and a 2, my sum is 3, a 1 and a 3, and so on. So I'm just going to fill in my table quickly. I roll a 2 and a 1, that's 3. This is going to help me keep track of all the sums. So 7, 8. Kind of squished in the corner there. Okay, so first I'm looking at the probability of rolling a sum greater than 8. So going through my table, I have greater than 8. It's not equal to 8, it would be anything more. So I've got 1, well, it's not a good way to show. So I got 1, so sum greater than 8, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so sum greater than 8, the probability would be 10 out of, and I got to see how many numbers I have here. So if I roll a 6, 1 dice of 6 and 1 dice of 6, there's 36 options in my table, right? It's a 6 by 6 table. Now looking at rolling doubles. So rolling doubles would be a 1 and a 1, a 2 and a 2, a 3 and a 3, 4 and a 4, 5 and a 5, and a 6 and a 6. So there's 1, 2, 3, 4, 5, 6 doubles. So remember with the formula, we're adding that in. And then we can even see here with our highlighting, we end up having 2 overlaps. So 10 and 12 are the sum for 5 and 5 and 6 and 6. So we need to subtract off those 2 overlaps. So I would have 10 out of 36, oops. Not paying attention here. I've got 10 out of 36 plus 6 out of 36 minus 2 out of 36. So that's going to give me 14 out of 36. And remember, you can reduce to lowest terms, like both numbers here are even. So I could divide top and bottom by 2 to get 7 out of 18, right? Okay, and then in the last example, in North America, the probability of being left-handed is 10%. The probability of having red hair is 6%. The probability of having neither of these traits is 85%. What's the probability that a randomly selected person will be left-handed and a redhead? So this is very similar to the question before about taking French and Spanish. So a Venn diagram would help us to organize our information here. We're looking at 2 characteristics, so being left-handed and having red hair. So we're told 10% of people are left-handed. So remember, that's the entire left-hand square or circle. So it wouldn't be putting a 10 here because we need to include this area over there. So we got to watch where we put numbers down so that they're included. So the probability of having neither of these traits is 85%. So we can put that in. Now notice they don't give you a total, but you can notice that these are out of percents, and percent means out of 100. So that means any of these numbers, or our total here for the amount of people that we're looking at, would be based out of 100. So obviously in North America, there's more than 100 people, but they took that stat and they changed them into percentages. So with that, we know that 85% are neither, so they'd be in that outside space here. So if we take 100, the whole area, take away what we've used up, that means we have 15% left. So with left-handedness, we have 10%, and I'm included in that 10%. I don't know if you've noticed, but I write with only my left hand. And then red hair was 6%. And so if we add those two together, we're at 16, which we can see that we're over by 1. So that means in our overlap space, there's going to be 1. And then we know left-handed needs to add to 10. So 10 minus 1 is a 9. And red hair needs to add to 6. So 5 plus 1 is a 6. So once we got the Venn diagram, we can answer the question. What's the probability that a randomly selected person would be left-handed and redhead? So that would be the overlap space in the middle. So that is 1%, right? That number is as a probability already, because it's written as a percent, then our total would be out of 100. So 1% is the answer. Okay, so you're going to do the practice questions on page 340 of the textbook. They are attached in the assignment, and so you can just find the pictures and answer key of those. Make sure you're showing your work. All right, guys, have a good day.